In February of last year, excitement ran high as NASA successfully landed its Perseverance rover on Mars. This incredible feat marked the beginning of a busy period for Perseverance, as it roamed the Martian surface for over 15 months, collecting data and performing groundbreaking tasks. Recently, NASA released a photograph showing an unusual shape on Mars that closely resembled a classic UFO, sparking online debates about the possibility of extraterrestrial life. The unusual find has generated curiosity and prompted questions about the existence of other life forms in the universe. The Perseverance mission has been a journey filled with breathtaking moments, including the deployment of its parachute and the significant deceleration during its descent. Capturing real footage of a Mars landing, NASA offered the world a rare glimpse into this incredible mission. When a strange shape appeared in a Mars image, the discovery led to debates and inspired calls for further exploration of the UFO-like sighting. Known affectionately as Percy, the rover was designed as a car-sized, remotely operated vehicle, unlike typical RC cars, and packed with cutting-edge instruments to search for traces of life on Mars. Equipped with 7 high-tech science instruments, 19 cameras, and 2 microphones, Percy was well prepared for the mission. Its Mastcam Z, a high-definition camera capable of capturing close-up shots of Mars terrain, quickly became popular among space enthusiasts worldwide. NASA set up a dedicated Twitter account where followers could keep up with Percy's journey and witness the stunning images it sent back. The rover had a few key goals. First, to search for areas on Mars that might have once supported life, such as water-rich regions, and second, to hunt for signs of ancient organisms. Percy also began collecting rock and soil samples, which future missions will retrieve and bring back to Earth for further analysis. By May 2022, Perseverance was climbing a Martian hill to study new rock formations that could hold more clues about ancient life. As it rolled back down, it continued collecting samples for future retrieval. After over 3 years of exploration and discoveries, one of the most talked about images from Percy's mission, taken on April 20th, 2021, captured the public's imagination, especially among UFO enthusiasts. This aerial shot of Jezero Crater, the mission's primary exploration site, featured a dark spot in the background resembling a crashed UFO, drawing widespread attention and leading to numerous theories, the most popular being that an alien spacecraft had crashed on Mars. Before diving into this mysterious object, understanding Jezero Crater is essential. This remarkable crater spans an impressive 45 kilometers and is located on the western edge of a region called Cetus Planitia, north of Mars's equator. Situated within the Serranius Major region, Jezero Crater has attracted researchers who believe it was once covered with water, possibly forming an ancient river delta. Millions of years ago, a large meteorite hit Mars, creating a massive crater, later struck again by a smaller meteorite, forming Jezero Crater. The area has yielded evidence of an ancient river that once flowed into it, shaping a dried-up delta and depositing clay, a material that can only form in the presence of water. This unique setting makes Jezero Crater an ideal site to search for ancient life on Mars. Scientists involved in the Perseverance mission have found the crater so intriguing that they named features within it after notable places on Earth. For instance, the rover's landing site is called Octavia E. Butler Landing, after the famed science fiction writer. The presence of clay and the river delta remnants make Jezero Crater a perfect spot to study Mars' geological past and search for traces of life. The unusual object in Jezero Crater stirred intrigue and speculation. With a curved edge, raised rim, and small indentation in the center, the object bore a resemblance to a crashed flying object, evoking comparisons to the 1947 Roswell incident in the United States. Scientists, however, were quick to dismiss the idea that it was an extraterrestrial spacecraft. The strange formation was likely an unusual rock or shadow, but it ignited widespread curiosity and raised questions about the possibility of life beyond Earth. Some skeptics suggested that the object could be a rock formation or even a camera anomaly. NASA clarified that it was a shadow caused by a small piece of dust on the rover's camera, visible only in one image and absent in others. The image's composition, created by stitching multiple pictures together, made it challenging to interpret. NASA emphasized that while space exploration often reveals mysteries, Its primary goal with Perseverance is to study Martian rocks to find signs of past life, not to seek evidence of alien spaceships. The agency concluded that the mysterious object was likely an illusion, reminding us that while space exploration is exciting, sometimes the simplest explanation is the most likely one. Science has long relied on principles like Occam's razor, which suggests that the simplest explanation is often the most accurate, especially when exploring complex phenomena like potential UFO sightings. Mars offers a unique environment with volcanic rock formations that can create unusual shapes and shadows. In this case, scientists believe the strange object was nothing more than a rock formation shaped by volcanic activity in the Medusae Fossae Formation, an area known for its volcanic remnants. Other theories about unusual radio wave reflections in the area were explained by the scattering effect of volcanic ash layers. Occasionally, early interpretations of Mars images lead to misconceptions, as with previous blurry pictures that some mistook for insect-like creatures, but were later identified as mere rock formations. Occam's razor helps scientists stay grounded, focusing on the most reasonable explanation before considering more far-fetched possibilities. Science also employs the principle of falsifiability, introduced by philosopher Karl Popper, which states that a theory should be disprovable to be scientific. In other words, a claim must be testable to be valid. For example, asserting that invisible aliens reside on Mars is not scientifically valid because it's impossible to test. However, proposing that visible Martian aliens could be found with rovers and cameras is testable and therefore scientific. This ability to test and potentially disprove ideas is a core aspect of science that separates it from mere conjecture. As technology advances, scientific theories can be refined and even overturned, as seen with long-standing theories such as gravity, relativity, and evolution, which continue to be tested and refined. Falsifiability addresses the challenge of induction, which involves forming scientific laws based on repeated observations. By ensuring that theories can be tested and are logically sound, science can maintain credibility even when a single experiment cannot fully disprove a theory. Although some scientists argue that falsifiability is overly strict, real-world experiments often rely on educated guesses known as auxiliary hypotheses to run tests. The peer review process, a crucial step in a scientific inquiry, further ensures accuracy by requiring that theories and discoveries undergo rigorous scrutiny from other experts in the field. Back in February of last year, you may remember the excitement when NASA successfully landed its Perseverance rover on Mars. Since then, it has been busy for the past 15 months, conducting plenty of roving. A recent NASA photo revealed an unusual shape on Mars resembling a classic UFO, sparking discussions about a possible extraterrestrial presence. This discovery prompted inquiries into other potential inhabitants of the universe. In one thrilling moment during the mission, the parachute deployed, signaling significant deceleration, and real footage of a Mars landing was beamed back, documenting this incredible event. NASA's documentation of this Martian anomaly has triggered online debates and urged further exploration of the intriguing UFO sighting. Perseverance, often nicknamed Percy, is a car-sized rover, not the typical remote control vehicle. When it landed on Mars in 2021, it carried sophisticated technology with a mission to search for signs of life that might have existed there long ago. The rover is packed with advanced equipment, including 7 scientific tools, 19 cameras for capturing images, and 2 microphones. One notable camera, Mastcam Z, can produce high-definition, close-up shots of the Martian terrain. NASA even created a Twitter account so that followers worldwide could track Percy's journey and enjoy the spectacular views. The mission of Perseverance is vast and significant. First, it searches for locations on Mars that might have been suitable for life, particularly areas that once contained water. Then it investigates possible traces of past microorganisms. Perseverance has also started collecting rock and soil samples to return to Earth in the future. In May 2022, Percy began climbing a hill to examine rocks for signs of ancient life, gathering samples along the way. These samples will eventually be retrieved by future missions and brought back to Earth for close examination. Today, after more than 3 years on Mars, Perseverance continues to uncover amazing discoveries. One of its most widely shared images, taken on April 20th, 2021, showed an aerial view of Jezero Crater, the rover's exploration site. A dark shape in the background caught many eyes, appearing as if it were the silhouette of a crashed UFO surrounded by Martian soil. Before exploring this object in Jezero Crater, it's essential to understand the area itself. Jezero Crater is a massive 45-kilometer-wide indentation on Mars' western side of Acetus Planitia, a region situated north of the Martian equator. Scientists believe this area may have once contained water, as it was likely flooded in the past, forming an ancient river delta. The crater sits in Acetus Planitia, where a giant meteor struck long ago, creating a 1,200-kilometer-wide crater. Later, another meteor hit within this area, forming Jezero Crater. The presence of clay in the crater, which only forms with water, makes it a prime site to search for evidence of past life on Mars. Perseverance's landing site was named Octavia E. Butler Landing after the science fiction author. When the mysterious object in Jezero Crater was discovered, its odd curved shape, raised edges, and small dent in the center drew interest, with some comparing it to a crashed flying object. This stirred memories of the Roswell incident in 1947. While scientists didn't believe it was an alien spacecraft, the unique shape fascinated many, sparking debates about life on other planets. NASA later explained that the unusual shadow in the photo was likely caused by a small dust particle on the camera lens. Only one image captured this shadow, which didn't appear from any other angle. NASA emphasized that exploring space is complex and often filled with unknowns. Although alien spacecraft weren't found, the strange shadow highlighted people's persistent curiosity about life beyond Earth. Falsifiability, a core principle in science introduced by philosopher Karl Popper, asserts that scientific theories must be testable to be credible. For instance, a theory that aliens on Mars are invisible would be unscientific because it can't be disproven. Instead, if we hypothesize that aliens can be detected using rovers and cameras, this theory is testable, guiding the search for extraterrestrial life. Good scientific ideas allow for testing and potential disproof, distinguishing scientific inquiry from mere guesswork. Even widely accepted theories like gravity and evolution undergo continuous testing and refinement. Falsifiability addresses the problem of induction by making sure theories are clear and testable, enabling logical analysis even if single experiments don't always disprove them. Another vital component in scientific research is peer review. It serves as a quality check, where scientists assess each other's work to ensure accuracy and credibility. In peer review, scientists working in the same field examine every detail of an experiment, from design to data analysis, to confirm the research's quality. This rigorous process helps catch errors, refine research, and improve overall reliability. Although not flawless, peer review remains one of the most effective ways to validate scientific research. However, scientists also encounter cognitive biases like apophenia and confirmation bias, which can affect objective judgment. Apophenia, the tendency to see patterns where none exist, can lead scientists astray. A researcher might interpret an odd rock formation as an alien spaceship due to confirmation bias, which reinforces pre-existing beliefs. Apophenia manifests in various forms, like pareidolia, seeing faces in clouds, or the clustering illusion, perceiving connections between unrelated events. For example, individuals might believe crop circles were created by aliens instead of human pranksters. Apophenia likely stems from survival instincts, where early humans learned to detect patterns to evade danger. These biases may influence scientific inquiry, emphasizing the importance of objective scrutiny. When investigating unidentified aerial phenomena, UAP on Mars, scientists must balance curiosity with critical thinking, weighing all evidence impartially. The search for extraterrestrial life combines science, philosophy, and ethics, pushing humanity to examine its place in the universe. The ethical dimensions of space exploration, including privacy and autonomy for possible alien life forms, raise questions about our responsibilities as explorers. As we investigate these phenomena, we are challenged to consider the moral implications of encountering intelligent species and the impact such a discovery could have on humanity. The search for extraterrestrial life is a profound journey, not only for scientific discovery, but also for understanding our existence within the cosmos. The quest invites us to consider our purpose, our place in the universe, and our relationship with other potential life forms. In 1976, the Viking 1 spacecraft captured an image of a geological formation on Mars, known as the Face on Mars, located in the Cydonia region. At an altitude of 1,873 kilometers, the photo revealed a human-like face measuring 1.2 miles by 0.7 miles. This image sparked widespread curiosity and discussions about life on Mars, drawing both scientific analysis and public intrigue. Falsifiability is a powerful tool, but it doesn't work alone. Imagine a scientist with an innovative idea about detecting aliens on Mars with rovers. Falsifiability helps this scientist design a solid experiment to test the idea. But how can they ensure the experiment is on the right track? This is where peer review comes in. Peer review functions as a team of expert reviewers providing critical analysis on the experiment's design, methodology, data analysis, and interpretation of results. The reviewers, scientists in the same discipline, meticulously evaluate the research, acting as quality control to ensure scientific research is accurate, sound, and of high quality. Think of peer review as a science quality check. Most scientific journals require research to pass through this process before publication. Peer reviewers act like detectives, identifying mistakes, biases, and even cases where someone might fabricate data. This process not only enhances research credibility, but also strengthens its influence within the scientific community. For instance, a researcher investigating the existence of life on Mars would receive assessments from Mars research experts, which could result in critical feedback that helps refine their work. Peer review is not just about finding errors, it's also collaborative. Reviewers often suggest improvements that the scientists can use to refine their work, fostering an environment akin to working with the finest minds across the globe. This collaborative effort hones critical thinking and leads to even more precise experimentation. Peer review essentially functions as a scientific quality control process, ensuring that published research meets the high standards expected by the scientific community and is trustworthy. However, peer review is not flawless. For some, the process can be slow, and reviewers may have biases or overlook certain aspects. Yet studies show it remains an effective tool for identifying errors, enhancing research quality, and fostering trust in scientific findings. While falsifiability and peer review drive science forward, they are not without challenges. For instance, scientists studying UFOs on Mars face added complications in detecting errors and avoiding personal biases. The human brain naturally identifies patterns, sometimes even when they don't exist, a phenomenon known as confirmation bias, where we prefer information that confirms our beliefs. For example, an ardent alien enthusiast might interpret a blurry photo of a Martian rock as a spaceship. Apophenia is another cognitive bias where unrelated things are linked, like seeing shapes in clouds. Confirmation bias can lead to misinterpretations, such as interpreting crop circles as alien messages rather than hoaxes. Apophenia, though common, highlights how our brains search for meaning, a survival instinct from early human life when pattern recognition could mean the difference between life and death. Types of apophenia include pareidolia, clustering illusions, confirmation bias, and the gambler's fallacy. Pareidolia involves perceiving images or sounds in random elements, like faces in rock formations. Clustering illusion occurs when we see patterns in random data, while confirmation bias makes us accept only information that reinforces existing beliefs. The gambler's fallacy mistakenly assumes previous outcomes affect future ones, even when unrelated. Apophenia often leads to false positives, as individuals assign unwarranted significance to random data. While more common in healthy populations, these biases may also indicate psychosis risk in vulnerable individuals. Everyday examples include hearing one's name in noise, seeing shapes in clouds, or believing in astrology and lucky charms. Apophenia can also lead to paranoia or delusions in people with schizophrenia, who might think media patterns are threats. Recognizing these biases is vital in the search for truth, especially in the study of phenomena like UFOs on Mars. Rigorous scientific scrutiny helps distinguish reality from illusion and advance our understanding of the universe. Studying unidentified aerial phenomena, UAPs, on Mars and beyond, carries significant implications. Critical thinking is essential, balanced with skepticism and evidence-based conclusions. Research should be grounded in verifiable data, avoiding presumptions, while humbly accepting differing viewpoints. This approach encourages open discussions where varied perspectives can be shared without fear. Discovering UFO phenomena on Mars is vital for understanding extraterrestrial life, with scientific, philosophical, and ethical consequences. Scientifically, such discoveries help explore natural laws and expand knowledge. Philosophically, they challenge our concepts of existence, while operationally, UAP analysis leads to experiments, model development, and deeper understanding. Ethically, studying UAPs involves moral considerations, obligations, and respect for other life forms. The potential discovery of extraterrestrial life could profoundly change humanity's self-concept and societal beliefs. This search brings complex moral questions, such as whether we should focus solely on studying cosmic phenomena or allow UAPs privacy and autonomy. Should UAPs have the freedom to explore, or should we safeguard them and their environments, respecting their possible rights? Balancing mutual respect and acceptance with the risks and benefits of such interactions will help guide research on UAPs. Encounters with intelligent species may impact humanity significantly. Thus, ethical and philosophical considerations should shape our research. The pursuit of extraterrestrial life extends beyond mere scientific curiosity, touching upon enrichment, mindfulness, duty, and respect. Space exploration reveals more than just physical discoveries. It illuminates our understanding of the universe and our role within it. The famous face on Mars in the Cydonia region is one such phenomenon. First captured by NASA's Viking 1 in 1976, the geological formation resembled a human face, sparking theories about ancient civilizations on Mars. Some hypothesize that it might have been part of a larger complex, possibly a city or base, with religious or artistic significance. However, NASA attributed this to pareidolia, where humans perceive familiar shapes in random patterns, and stated it was likely shaped by natural erosion over millions of years. Similar rock formations in Cydonia reinforce NASA's view that the face on Mars is a natural geological feature, not a relic of extraterrestrial activity. Another Martian mystery is the Phobos monolith, a large rectangular object on Mars's moon Phobos. Captured by NASA's Mars Global Surveyor in 1998, its origins remain speculative. Some suggest it is a naturally occurring rock, potentially from volcanic activity or an impact. NASA has not provided a formal explanation or sent a mission to study it further, keeping it an open question in the discussion of extraterrestrial life within our solar system. Saturn's hexagon, a mysterious six-sided storm on its northern pole, is another unexplained phenomenon. First observed in 1981 by the Voyager 1 spacecraft, the hexagon is an atmospheric formation approximately 32,000 kilometers across, with winds reaching 500 kilometers per hour. Despite extensive research, scientists have not determined its origin. Some suggest atmospheric dynamics, while others propose extraterrestrial influence. With no known signals or transmissions from Saturn's hexagon, it remains an enigma, fueling ongoing curiosity within the scientific community. The bright spots on Ceres, a dwarf planet in the asteroid belt, add yet another layer to the mystery. NASA's Dawn mission, which explored Ceres between 2015 and 2018, discovered bright areas in the Achater crater, primarily composed of sodium carbonates. Scientists speculate that briny water from within Ceres surfaced, evaporated, and left behind a reflective crust. Though researchers have identified the chemical composition, some suggest the lights might be artificial structures linked to extraterrestrial life. Despite the interest these lights have garnered, NASA has not conducted extensive research on their origins, leaving them classified as unexplained phenomena. Another fascinating discovery involves Europa, a moon of Jupiter, where mysterious plumes resembling geysers were detected. In 2012, the Hubble Space Telescope observed water vapor plumes erupting from Europa, later confirmed by the Galileo spacecraft. These plumes may offer a chance to analyze Europa's composition without drilling through its icy crust. A 2020 study suggests these eruptions could be caused by freezing and pressurization processes within Europa's crust, rather than from a subsurface ocean. Europa's oxygen-rich atmosphere forms when solar radiation collides with its icy surface, creating water vapor that dissociates into oxygen and hydrogen. The study of Europa, along with other space phenomena, provides valuable insights as humanity continues to explore the mysteries of our solar system. Thank you for joining us. Stay tuned for more updates on the latest discoveries and insights from NASA's exploration efforts.